I'm doing the new assignment, sound interactions, and the Doppler effect. I'm going to have this PowerPoint open in one screen, and in another screen, I'm going to have the quiz open, so I can do those both at the same time. So I'm going to use my email. Oh, it automatically put my name in, and today I'm going to pretend like I'm a student in second period. Okay. So I have this open in one screen and this PowerPoint open in another screen. So I have the PowerPoint in one screen and I have the quiz in another screen. I can see what the questions are. What does the Doppler effect sound like? So I'm going to answer that. I'm going to answer that with 20 words or more. Why does sound travel faster in a solid? I'm going to answer that with as many words as necessary. Why is there no sound in space? Again, as many words as necessary. And what is one way that sound waves are different from light waves? I'll be answering that with as many words as necessary. This says one way, so that implies that there might be more. Here's a multiple choice question. Which surface does more sound reflect from? A harder or a softer, or they both reflect the same? And then a discussion about echoes. So today's work requires me to write, do some writing. Okay, first question, what does the Doppler effect sound like? I'm opening the document, the Doppler effect. So the Doppler effect is the way that sound waves sound when the object that's emitting, that's making the sound, is coming towards us and then goes past us and goes away. So that's the Doppler effect. It's the change in pitch or frequency as the sound gets closer to you. And this is an illustration of what the sound waves are doing as they get closer. They compress. So the same number of waves are expanding to fill a larger distance, and the motion of the source is that direction. And the same number of waves are compressed in a smaller distance. The Doppler effect. The closer a sound gets, the higher the pitch, like an ambulance. As it goes up and then it drops. The pitch sound changes. The farther away a sound gets, the lower the pitch. The Doppler effect. You can draw this if you want. Doppler effect for a moving sound source. The low wavelength, low frequency, small wavelength, high frequency. I'm going to watch this video. One more.
It's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
That was fun. So now I can answer. What does the Doppler effect sound like? And you could write something about how he made that sound. So the pitch drops as the object moving relative to an observer passes by and moves away. 20 plus words. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. The sound changes from high to low. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, the next question. Why does sound travel fastest in a solid? How does sound travel through different states of matter? In old Western movies, a cowboy would put his ear against a railroad track to listen for a train in the distance. Why do you think they did this? Sound travels through all forms of matter. It travels through solids, liquids, and gas. Why should you not tap on a fish tank? Sound travels through all forms of matter, solid, liquid, and a gas. The speed of sound depends on the medium it travels through. A medium is a solid, liquid, or a gas. The speed of sound. Sound travels through the air at 343 meters per second. Light travels at about 300,000 kilometers per second, or 300 million meters per second. The speed of sound. Sound travels through water at a much faster speed, 1,493 meters per second. Light travels at about 225 kilometers per second through water. The speed of sound. Sound travels through steel the fastest at 5,940 meters per second. Light cannot travel through steel. Why does sound travel fastest in a solid? And here is a comparison of the speed of sound in air, water, concrete, and steel. Solid. The molecules are packed tightly together, so the vibrations can pass from one molecule to the next much faster than in air. Liquid. Molecules are close together. In a gas, the molecules are spread apart. Sound travels fastest through solids because the molecules are tightly packed together. And I'm going to use that slide there to answer this question. Sound travels fastest through solids because the molecules are tightly packed together. Sound travels fastest through solids because the molecules are tightly packed together. Next question. Why is there no sound in space? Sound travels fastest through solids in a vacuum, a place where there is no molecule. Oh, there are no molecules. There are no molecules for the sound to pass through. There is no sound in space because there are no molecules. There is no matter. There is no matter. No medium for the sound to pass through. All right. What is one way that sound waves are different from light waves? We'll look for that next. A tiny piece of space junk hits the space shuttle. There are two astronauts in the picture, one inside the capsule and one outside. Can either one of them hear the impact? Well, if space junk hit the capsule, then the sound would pass through the steel in the capsule and through the air, and the person inside would be able to hear it. The sound would not travel through nothing. It needs a medium, so the astronaut outside would not hear it. The astronaut in the space shuttle can hear the impact because there's air in the space shuttle for the sound to travel through. The astronaut on the spacewalk can't because there's nothing between her and the impact to carry the sound. There is no sound in space. Here's a speed of sound table, and diamonds have the fastest speed of sound, tightly packed molecules. And we'll watch this video.
Watch the vapor build up on this airplane. Look at that. Oh, yeah!
Okay, you can watch some more of that if you want to. This other link does not work. Summarizer. We're going to compare and contrast a sound wave to what you know about light wave. This looks like it's going to answer the question, one way that sound waves are different from light waves. One way that sound waves are different from light waves. Sound, the particles of a medium move back and forth. And in light, the particles of a medium move up and down. So that's one way. We could use that one. In sound, the particles move back and forth. And in light, the particles move up and down. You could use one of these other ones too. In sound, particles travel fastest in solids, and in light, travel fastest in the empty vacuum of space. Sound has compressions and rarefactions. Here's a compression, here's a rarefaction. And light has crests and troughs. Sound is mechanical, it must have a medium, and light is electromagnetic. No medium is needed. In sound, the particles of the medium move parallel to the direction of the wave. They move like this. And in light, the particles of the medium move perpendicular back and forth like this. They're the same this way. They both travel as a wave, they both transfer energy, and they both can travel through a medium, except light cannot travel through a medium like steel, but it can and they both can travel through a medium, and they both can travel through a medium. Here's some sound wave videos. You can watch these. This is the coolest things that sound waves do, and you can watch this. All right, next questions. Which surface does more sound reflect from? Interactions of sound waves. What are the interactions sound waves undergo? Here is the sound being emitted or being made. Here it's passing through and continuing on. Here it's been absorbed. That means that the energy from the sound is moved into this surface. And it's actually going to heat it up a little bit, tiny amount. It makes the particles move a little faster, and that's the definition of increasing the temperature. And here the sound is reflected, so the energy from the sound is bounced off and will go a different direction. Sound reflects back. Reflection is the bouncing of sound off of a surface. Absorption. This is the disappearance of a sound wave into a surface. The harder the surface, the more sound is reflected. That sounds like our question. Which surface does more sound reflect from? looks like it reflects from a harder surface. The softer the surface, the more sound is absorbed. Discuss echoes. Echo, 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 echo. That's when you yell into a space and there's something there that reflects the sound back to you, and you can hear the sound come back to you just after you have said it. So, echo, echo, and it bounces off. This is showing a picture of a canyon because people will frequently send a sound into a canyon and you'll hear the reflections from different surfaces at different times. Echo, 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 echo. It's a reflected sound wave, and the sound reflects back. It's echo is communication. Dolphins and submarines use echo, echolocation, the finding of an object using reflected sound. Sonar is the finding of an object using reflected sound. So, the difference between echolocation and sonar. Sonar is ships and submarines, and echolocation is dolphins and bats. And here's a video of a boy who could see like a bat. And you can watch that video if you want to. Discuss echoes. Echoes are reflections of sound from objects. Some dolphins, bats, and ships and submarines use sound to locate objects. And we could submit this, and we're done.